So the first thing that you gotta make sure you understand is the kinetic molecular theory, or KMT, okay? We have seen that when we did states of matter. Does anybody remember what that is? What does the word kinetic tell you? Moving and molecular molecules? Yeah, exactly. All right. So it's moving molecules. So it means particles in constant motion. Okay? All right. So particles are in constant motion. So when we go to look at our gas laws, and so what that kind of is specific to is even in your solids, things are wiggling around. So gas laws are really, this is a huge idea for that because it's talking about how environmental factors are going to affect how those particles are moving in their constant motion, okay? So a couple of the vocab words that you guys need to be familiar with is going to be pressure, temperature, and give yourself room, like 2 lines for each one. Volume, moles. Okay? So pressure, temperature, volume, moles. So each one of these has a variable that you'll be using in one of our equations, which I'll just put up here so you can kind of see what it's going to look like later. We call it PIV-NERT. All right, so PV equals nRT. You will have to plug into this one, and there's a problem like that on your review. Okay, so pressure is obviously going to be the P. Temperature is going to be the T. Volume, V. And moles is going to be N. We'll come back to the R later, okay? Each of these have certain units that you're going to want to look for. So pressure is going to be given to you in one of 3 or 4-ish units, okay? Atmospheres, kilopascal, or torr, which is also known as millimeter mercury. If you don't know these, I don't care. We're going to get to that later, okay? So ATM, KPA, torr, T-O-R-R, it's a dude's name, and millimeter mercury. He came up with the millimeter mercury thing. That's why we use his name in millimeter mercury. I'll go into that later, though.
Is that a T or an H?
HG, mercury. All right, so pressure. What is pressure? All right, so I want you to think about what you know about pressure. Okay, so think about leaving a can of soda in a hot car. What is it gonna? What happens usually? It usually explodes, right? So what can you tell me built up in it? Most likely. Did we add more soda in there as it sits in the car? No. So what do you guys think is happening as it sits in a hot car? What did you say? No. What did you say? All right, so she said it gets hotter, so it bubbles up and then it explodes. And then I heard him say builds up pressure, right? So basically, things are going to kind of speed up in the car. And we'll get to that later. And what that means is that pressure builds up. So when I'm saying pressure, you can kind of imagine all those molecules like hitting the sides of the soda can. Can you guys kind of picture that with me a little bit? So they're hitting the sides of the soda can so hard that now it's going to explode. Okay? So pressure is merely collisions. Okay? And that's the word that I want you to remember. They are collisions. So, another analogy is that if you guys are flailing around, meaning your arms are all waving around and stuff like that, and I move you guys all into this little itty-bitty corner, are you guys going to be hitting each other a lot? Are you going to have a lot of collisions? Yes, right? But if I spread you guys out, are you going to have as many collisions? No, less pressure, okay? All right, so collisions is pressure. All right, temperature. Who wants to take a stab at that one? Oh, wait, let's write our units first. Sorry. It'll be Celsius or, oh, not T. And not Fahrenheit, darn it. Kelvin. You're in science class. Okay, we do not use Fahrenheit. Don't you dare. That's a USA thing. Don't do it. Okay, all right. So for temperature, what do you guys think that is? So I already kind of told you a hot car, particles are going to start banging against the container. Why are they doing that? What's happening to them with temperature? Not heating. Okay, yes, they're heating up. But what is that doing to the particles? We're talking about what those little things are doing. Making them what? Making them move more. I like that. All right. So it means they're speeding them up. Okay. So we're going to put speed next to this one. Temperature is proportional to speed. Okay. Some people will say temperature is a measurement of speed. It really technically isn't, but I'm okay with you thinking that way. Okay. It's an easier way to think of it. So temperature is proportional to speed, meaning as I crank up the temperature, everything speeds up. So if it gets hot in here, if I crank up the temperature in here, it means you guys are like running all over the place. So what happens to collisions? They're going to increase. So we've already seen a little relationship here. If I crank up temperature, pressure is going to go up. It's a direct relationship, okay? If I lower temperature and everybody slows down, are you going to be hitting each other as much? No, less collisions. Okay. All right, let's go to the next thing. Volume. What unit for volume? Liters is correct. Good. And since we are dealing with gases, we want them pretty much only in liters because we need a large sample of them. Okay? All right. So volume is amount of space. I think you guys know that. And then finally, moles. I bet you can't come up with that unit. It's the mole. Really? Really? It's the mole. M-O-L. What you guys have been doing. All right. So, moles is just how much stuff. Okay, how many particles did you put in there? What's your sample size? Okay? All right. So, what I want you guys to do with these is now I want to kind of come up with a couple of these relationships so that you have your gas laws pretty much in a nutshell without me giving you special names for them because we'll learn those later. But you're going to start seeing that some of these posters around the room are referring to that, okay? So let's talk about the pressure, temperature. So you can write on either side. I don't know which side you have more space on. Or you can write it below. Okay, so as I crank up temperature, what did we say? As you increase temperature, what happens to pressure? Pressure increases. Okay, so you guys see this toilet paper up here? This toilet paper? If you've been wondering what it is, this is what it is. It's talking about TP. All right, this is Gay-Lussac's law. Has to do with that. So it's a direct relationship between temperature and pressure. Okay? It's his name. I said that's his name. You'll see. What? Constant. You'll get there. Okay. All right. So let's talk about moles and pressure. If I stuff more people into this room and keep putting more people into this room, what's going to happen to the number of collisions? That's also going to increase. So if you increase moles, you also increase pressure. Okay? We'll come back to volume in a minute. All right. So with temperature, let's relate that one to volume real quick. So let's do moles and volume first. So I want you to think about a balloon. You guys have all blown up a balloon before, right? No. At one point in your life? Please tell me you have. Oh my goodness. All right, so a balloon, okay? And you have your balloon. You're blowing air in there, right? Okay. What happens to the volume of that balloon? It increases, right? So as I increase moles, I'm increasing, oh man, sorry, I'm increasing volume. Okay? All right. Has anybody seen the demonstration where you have a balloon and it's inflated and then you take it into a cold place or you put one in the refrigerator or the freezer? What happens to it? It contracts, right? Everything comes down. So, what can you tell me about temperature and volume? If I increase temperature, what's going to happen?
Increase volume.
That's going to increase it. So you guys have heard of hot things are going to expand, right? You guys have heard of that? Thermal expansion. Okay, so same kind of idea here. So if I increase temperature, increase volume. Okay? It also means that if I decrease volume, no, never mind, nothing. We're going to go away from that. All right, so as you can see, everything is directly related to each other, except let's talk about pressure and volume. This is the weird one, okay? So pressure and volume. All right, let's see here. If I have a big classroom, you guys are all in it, and I made it smaller, what did you guys say happens to pressure? It increased, right? So as I decreased volume, pressure went up. Does that make sense in your brain?
Yes.
Okay, good. Okay, cool. So, so if you squeeze everything together, you're going to have a lot more collisions because you just decrease the space that they're allowed to move in. Okay? All right, so if you wanted to know, the TP one is Gay-Lussac's law. There's really not an NP one. It's a relationship, but we don't really learn that one. N and V is going to be Avogadro's law. V and T is going to be Charles' law. And then P and V is going to be Boyle's law. I don't need you to know that right now, but we're going to come back to that. The big thing that I need you to notice is this is the only one that's inverse. Everything else is directly related. Okay? Okay. All right, you guys good? Okay, I'm going to show you one last thing. So I'm going to squeeze this, move this up here. I'm going to move this over here. Okay, last thing to write down. Put PV equals nRT again. Okay, PV equals nRT. So we've gone over pressures, volume, moles, and temperature. So this R thing, look inside your periodic table. I want you to open it up and look at the chart of constants and conversions. I want you to try and find an R for me.
Pressure time.
Ideal gas constant, good. Okay.
Oh.
All right, what do you notice about it? Is there just one number? No, there's 3 different ones. So I want you to look across it, okay? Do you guys see all those little words and things? Here, let me see if I can get a picture up here. Maybe I can make it show up. Okay, you guys see that? All right, so on this little chart, it shows you all your different constants. Okay, what I want you to notice is that moles goes all the way across. You see that? What else goes all the way across? Temperature, okay, K's go all the way across. Cool, so that's temperature. What else? The L, so liters. So volume is the same all the way across. What's the thing that's changing in the units for these? Yeah, so who are all these things talking about? Pressure. All right. So the big thing with your R constant, in order to know which one to use, you always have to look at the units on your pressure. Now, one thing I do need to touch base on because it happens every year, this is not an equation. You do not plug into that. Those are the units. They are meant to cancel out all your other units. Okay? So please do not think it's 0.0821 times liters in atmosphere and all that. So, okay. Just need to touch base on that. Okay. So I'm going to move this up here, and we're just going to write down what each one is and when to use it. So we're going to say you will use 0.0821 if you see atmospheres. You're going to use 8.31 if you see got ahead of myself. Kilopascals. And then you will use 62.4 if you see torr or this millimeter mercury thing. They don't put torr on it, but it does exist. So, all right. So you have to look at which unit is being used in your problem. That's the big trick thing, okay? But you're going to be asked to solve for one of these variables. I think the one on your review, you're solving for this guy. So can you handle the algebra and do that? Hopefully. It was prereq for chemistry, so you got to know some algebra. Manipulate it. Okay. All right. So let's go ahead and look at the problems that they give you in your review. Because I just want to show one last thing. Because it asks you to apply Avogadro's law. So I'm going to show you guys that. Okay. So look in your review. We're looking down at number 10, 11, and 12. All right. So for number 10. Okay, and this is the way you should be approaching most of your problems. Go through it and figure out which variables you've got. So for number 10, we have 2 liters. So that's a volume. 5 moles. What letter do we use for that one? Remember, we have P, V equals nRT. So it's N. Good. What would happen to the volume, so V again, if the number of moles increased? This is a typo. It should say moles right here. All right. So we are looking, okay, for a new volume. Real quick, what happens if I increase the number of stuff in that container? What happens to volume? It gets bigger, right? Just like a balloon. This is about a balloon right here, okay? So this is Avogadro's law. Cool thing about that is you could either write it this away or you could write it this away. It really doesn't matter. It's the same relationship, okay? So it's whichever one you prefer. We're going to go with the first one for mine just because it makes the thing go on top. All right, so for this, you're given 2 and 5 for the first V and N. You're going to set it equal to, we're looking for V, they give you N. That's all it is. Can you handle that? It's cross multiplying. All right, so a lot of you guys are comfortable with that, but it's not everybody, so don't roll your eyes or anything at this. I'm going to show. Okay, so my people who are good at cross multiplying, or if you want to try it, you would go 10 times 2. What is that, everyone? 20 divided by 5. What is that? 4. All right, so the answer is 4, okay? If you don't like cross multiplying, you got 2 other options. If you do like it, then you just keep moving on. You can do the rest of this. If you don't like cross multiplying, another option you've got is I could do, when you do cross multiplying, you do the diagonals, you set them equal to each other. So it's 2 times 10 is equal to V times 5. So you would simplify one side. So I got 20 is equal to V times 5. These guys are being multiplied, so I'm going to divide both sides by the 5, and I'm left with 4 is equal to V. That's the second way, okay? I know people who are cross multiplying, just keep moving on. The last way, if you hate that, because some people do, you're going to plug in this to your calculator. So plug it in, and you get what number? What's 2 divided by 5? No, it's 0.4. Is equal to V over 10. How do you get V by itself? Multiply both sides by 10. So you end up with V equals 4 again. Okay? So you have all those options. Just wanted to be prepared for that. Okay? Other than that, number 11 is a pivnert. Okay? You have all that information. It's in kilopascals. So what R are you going to use? Which one? 8.31. Okay, because it's in kilopascals. And that's it. It's just plug and chug. And then you should be able to answer number 12. All right, so that's it for the gas laws. Like I said, I'm not going to grade you heavily on it because I taught you the day before. So don't freak out if it's going over your head. Make sure you're good at everything else, okay? Come in for tutoring